Welcome students. Today we are going to see the model driven engineering, okay, which comes under your system models, and that is also this is also one more important topic. In this model driven engineering, you need to do the modeling in such a way that where the principal output will be getting involved in your development process. Okay, so here in this model driven engineering, you have to work with your hardware and software platforms, and you have to see that how the principal output can be processed through your development process. Okay, that is the main thing here. So now moving towards the slide. Okay, so here you can see the first point. It is an approach where the software development models and the programs and the principal outputs of the development process. It means that this is a model driven engineering where we are going to work out on the models. Okay, if any system will be there in that system, how we are going to give some of the trigger point where we can drive that model towards your principal output. Okay, so that development process is nothing but that is known as your model driven engineering process. And also this program will execute on a hardware or software platform. Why it is called as your hardware or software platform? Because as we are considering about the model, so definitely it will be a system model, and without the hardware and software components, the system cannot be developed, right? That is the reason if we are writing any kind of the programs, all these things are going to execute on your hardware or software platforms. So all these things will do automatically, because here it needs some driving point towards which our system model can be driven out. And here you can see one more point, that is nothing but it is going to use the level of your abstractions. Okay, so we have already seen how the abstraction will works out. So here this is going to take place, it is going to raise the level of abstractions. Whenever we will use in the software engineering, the programs whatever you have used or execute inside the platform, everything has to be on your abstraction levels. So it is going to work out on your abstractions. So here 3 points I have mentioned. One is like the principal output has to be dependent on your development process, because if you want to drive any of the process, you need to find out the principal output first. Okay, and accordingly you have to drive the model. And also the second point says that if you want to execute your hardware or software platform, then it will automatically execute, because as we want to drive the model. And also the third point says that it is going to raise the level of abstractions, because we have to use different programming language in different platforms to execute our softwares. So that is model driven engineering. Now we will see what all are the uses of model driven engineering. Here one more point also, it is a very important point. This approach is in early stage of development. You have to remember this point. This is a very important point. This is a early stage of development. Okay, so what is the meaning of this? Early stage in the sense, software engineers, they used to develop any kind of your softwares, right? So this model driven engineering, now it is in the beginner stage. So what are some pros we got and some cons we got. Now in the next stage, we have to, the software engineers has to work on that cons, and they have to reduce the cons. Okay, so that this model driven engineering can be useful more in the future. Fine. So what are the pros? Let's see. It allows the system to be considered at higher levels of abstraction. That is a pros for this model driven engineering. Already we have discussed about your abstraction in the last slide. So here it is going to be considered about the abstraction process. And also it will generate the code automatically. Okay, if you are going to give any kind of code, some codes are there, it is not mandatory to write the code from starting to end. Okay, so you can use that platform and you can generate your code automatically. So here this model driven engineering supports this kind of code automatically, and it will adopt. Suppose if you have some code and if you want to run that code in some another platform, that also possible in your model driven engineering platform. Okay, so here you can generate automatically codes, and also you can adapt to execute the same old code in your new platforms. So now what all are the cons? Models for abstraction and not necessarily right for implementation. So here the con says whatever the level of abstraction we have been used, that is only used for the models. It is not used for the implementation part. Okay, so as it has not been used for the implementation part, so that is the cons for this. So now next stage, this is our early stage. Now in the next stage, it has to work on your implementation part so that we can utilize this. Okay. Next, what is the next one? Savings from generating the code may be outweighed by the cost of developing translators for new platforms. It means that if you are going to generate any kind of your code, like automatically you are generating any programming code, then that will be the cost, maybe it will be high, or maybe it will be more than the expectations for the new platforms. So that things also it needs to check it out. So all these things has to be checked out once you are going to develop for this model driven engineering. So now in the next slide, we will see the architecture, how the architecture has been designed for this model driven engineering. So the short form of your model driven architecture is known as MDA, which is also a general model driven engineering. Okay, this architecture is normally focused on your UML models. We have already done many kind of our UML models. So here also it is going to use the EML model, which is going to describe about the system. So if anything has come in the name of your system, that time this model driven will come into picture, because model is nothing but your system. And also one more point is there, that is in different levels of abstractions, whatever we have created, the higher levels of abstractions. So everything will be your platform independent in this model. And it will be possible if you are going to generate the working program without the manual intervention. It means that if you are going to write any of the, if you are going to execute the programming code in any of your higher level platform, then that has to be independent of your MDA, this one, MDA, like model driven architecture. And also it will be possible to generate the code for each of the program. So if you want to manipulate all these things, or if you want to manually do all these things, so that things are not possible here, because it is a very platform independent model. And if you want to generate the automatic code, then you can do in this model itself. So now let's see how many types of models are there. So definitely you will get the question, like it can come for your 6 or 8 marks of question. What do you mean by model driven engineering, and state all the types of abstract system models, whatever has been produced. So these things you can make get your question. So what all are the types of models are there? Here we have some 3 types of model which is going to be generated by your model driven engineering. Okay, so in this model driven engineering, if I will do one kind of your diagram, what you are going to write, the first one will be your computation independent model, next one will be platform independent model, next one will be your platform specific model. So you can have this also, but before that I'll just do one diagram. This diagram you have to draw right now, so because that is not there in this slide, so I don't have space also, I will do over here, and whatever I'm going to tell you, just write down here. So you are going to write types of model. Okay, so here I will write MDE. This is my architecture, right? MDA, so model driven architecture. Fine, so here it is like that. So next what you are going to do, how many types? It is of 3 types, right? One type, second type, and you are going to write the third type. This diagram you can do. What is the first one? CIM, you write down. Next one is PIM, okay, write down. Next one is your PSM. Okay, so these things are your 3 types. So here what you're going to give, you give the arrow marks. So this is of 3 types. You can do this extra diagram, and this diagram will carry some, at least some 1 mark. There is nothing to do much more things inside this, but you can do and you can get the marks easily. Okay, first you do this diagram and then you write the types of models. So now what is happening? What do you mean by this computation independent model? Which one is my first one? So how it is and all. So what I'm going to do is, this model, it is nothing but, you can see this is a domain abstractions. Okay, so now you can ask that, what do you mean by domain abstractions? So here, these domain abstractions you can utilize only inside the systems. Okay, so this system is nothing but, this is known as your domain models. So inside these domain abstractions, whenever you are going to utilize any computational independent things, like you can say independently, if you are using any hardware or software things, so in that way, if you are generating any kind of models, that is known as your CIM, that is a computation independent model. So the next type will be your platform independent model. So here what you are going to do, so definitely, as the name suggesting, that is a platform based independent model, then definitely whatever the model you will design, that model will be independent to your platform. Okay, whatever has been used for your executions, whatever the code you have written for the executions, and for executing that code, if you have used any kind of your platforms, so that platform will be very independent to your model in the sense model driven engineering process. And also the model has to be described by using this UML model, that is nothing but unified model language. So you have to utilize this model to show how your system is a static or dynamic structure, or if it is like responding towards any kind of your external or internal events. Already I have explained in the last class. So if it is happening anything into this, so all these things, all these descriptions you have to give inside your platform independent model. I repeat once again. So in this model, in this platform independent model, as the name is suggesting, the code whatever you have written, if you want to execute in any of the platform, then that platform will be independent to your model. And whenever you are doing that model or you are designing any model, so that has to be described towards your UML models. Okay, it can be static by nature or static by the structure, and if it is going to respond towards your external or internal events. Fine. So this is the second type of your platform independent model. Now the last type is known as your platform specific models. Okay, so what do you mean by platform specific model? So here you are going to transfer the models. Fine. So from where to where you are going to transfer? This is normally, it is a application platform. Okay, so you are going to transfer this platform independent model towards your platform specific model. Okay, so as it is coming under your application platform, you are going to convert or transfer your platform independent model to platform specific model. Fine. So here in this layer, what you are going to do, in each layer of this platform specific model, you can add your own details. If you want, if you have any specific details, you can add. Suppose you can take it as in, consider I have done the student database. Okay, so here I am going to do the student model. So what I will do, I'll just write down the student, and I have added the attributes name as name and USN. So now that I have done, I have written the code also and executed properly in my platform. Okay, that is known as my platform independent model. Now what I want to do is, I want to convert that one into my platform specific model. So what I will do, that name, I have written that only student, I have written only name and USN. So if you want to add any of the different layers to that, you can add. Like student name is there, you want to add the first name, last name. That also one more layer you can design and you can do. I'll just do it over here. You can see this is your student. Okay, so this student is having two things. One is your name and one is your USN. Fine. So now what you want, again one more layer you want to do, where you can go for your first name. Okay, and one more you can go for your last name. So if you want to do this kind of layer things, then you can utilize your platform specific models. So in this way you have to explain it, right? So this is all about your like types of model and variety of types, how you have used all the types, things and all. So this is these things can come for your some 6 marks or 8 marks of question, full description. Okay, so you need to write everything and all. So next we will see one, I have one diagram. We will see how that diagram and all is working out in our next slide. So moving towards your next slide. Okay, so here you can see the transformations. Okay, so here I have the translators. Here is the viewer. Fine. So here I have the translators. So what I'm going to do, I have my 3 models. The first one is my computation independent model. Next is platform independent model, and next is platform specific model. So all these things has to be connected with my translator, right? First, this model, CIM model, has to connect with my translator model. So it has to find out all the rules and regulations about the domains, whatever has been declared. So here it will have some domain specific guidelines which has to be translated and forwarded towards your computation independent model. First it will send and it will find out the domains. Again it will send towards your translator and moves towards your next label. That is, what is that next type? That is platform independent model. So once that will be done, again it is going to send towards your translator to find out if there is any rules forwarding towards your specific pattern rules. Okay, if it is there, then again it is going to send it back to my platform specific model. So here, as I told you, that it has to work out with your executable code. So it has to go for the code, because the code only has to execute inside your platforms, right? So here towards your translator, which specific language you want to use for your writing code, that you can translate and you can send it back to your executable code. So this is nothing but it is just a architecture of your model driven, how you are going to transfer from one one layers to another layers. Okay, so now moving towards your next slide, we will see here how the multiple platform specific models are going to work out. Okay, so if I will take care of only one layer, that is my second one, that is my platform independent model. So there are many translators are available, right? So if I will go for the J2E, that is Java translator, so I have to do I have to work on my specific model of J2E. If I'm writing the Java and if I'll write the C code here, it will not execute, right? So I should write only, I have to use a translator of J2E only. So here this is a Java code also will generate, and then you can write your Java program inside your platform independent model. In the similar case, if you want to go for the .NET translator, then you have to use the .NET specific model, and you can utilize the C hash code generator here, and you can write the C hash programs. So whenever you are using any kind of your translator in the sense, if you are using any kind of your programming language, so you have to go through your that specific model and you have to generate the code and you need to write the program. So this is all about your platform, multiple platform specific models. And this is everything is about your model driven engineering. So now I will write the question over here. I want to do context model of ATM system. Okay, so here see ATM system. Okay, I'll highlight this. Fine. So now how I'm going to do this, I know that for the context model, the first thing is I have to write in the center, I have to take one box, place over here, and I will write there ATM system. So you have to remember how you are going to do the diagram. That is first thing to remember. Next, what I'm going to do, I will take one more box, and sorry, I have to take one more box. I will place over here, okay, and I will write here for ATM system. I know that we have to keep the maintenance, so I will keep the maintenance system. I will keep the maintenance Okay, system. Fine. Okay, maintenance system. Next, what I want to do, I want one more. Okay, so I will take one more. I will write, I'll just place over here somewhere, and I will write down here account, because I need to have the account. So I will keep here as account system. Okay. So next, if I want to go for that, I will go for again. I will drag, drop over here, and I will write here counter system. If you want to add any other things as per you, that also you can add. Okay, no problem. So counter system. I want to go for one more, so I will write here. I want the security, so I will draw here and I will write down here security system. Security system. Next, again, if I want to take, so I will take one more and I will place over here and I will write down here as account, some database. If you want to create, I'll write here account database. Fine. Next, if I want to take, I will take here, I will place over here and I will write down here transaction database. Transaction database. Fine. So now I have to give the connectivity in between them. And remember, in your context model, you should give only the lines. Okay, you are not going to give again any other things. You have to give only the line connectivity. So I will connect here, then again I will connect from here to here, then again I will connect from here to here. All these things has to connect it to your ATM system. So if you will do this kind of diagram only for context model, you will get 4 marks of 4 marks. Okay, so this is about your context model. Now if I were okay, another question is there. I'll give you one more question. In the same way you can do, the question will be context model of patient management system. So if there will be patient management system, you need to do the diagram in a similar way. Okay, the context model of patient management system, you need to do it. I just write down the question. You have to practice this as an assignment. Okay, this is one assignment I'm giving to you all. Context model of patient management system. In the same way, this kind of question you will get. Patient management system. Fine. So this is your assignment. Please try this out. Okay. So now I want to go for your interaction model, where I can show you that only the use case of your some diagrams, sequence diagrams, or I can give you the sequence diagram of how you are going to withdraw the money from ATM. So that will be your sequence diagram. Okay. So how to do my sequence diagram? Now let's do that. Okay, so now I just move to the next page. So here I need some more page actually. I'll go for the next page. Yes. So here I'll just write down the question now. What I'm going to do now, sequence diagram for withdrawing money from ATM. So if this kind of questions will be there to draw the sequence diagram, how we are going to do it. So the first thing is what we have to do, we have to make 3 boxes. Okay, so I have to make the 3 boxes. So first I will take one box and I will give the names to that. Fine. So here one name, another box I will take and I'll write over here somewhere. So I'll give the second name. Then again I will take one more box and I'll place over here. That is my third one. Fine. So here in the first box, if I want to write, as it is a customer database, I have to take customer. So I'll write customer. Fine. So in the next database, if I want to add, that is my ATM system. So I'll write ATM system. ATM system. Okay. Now in the next box, what I want to add, I can add the bank because it has to be related with your bank, right? So all these things you need to write. So next what we are going to do, we have to draw the sequence diagram. I told you that always a sequence diagram will be in a serial wise, right? With a line, right? So here what I want to do, first I will put one line because it has to start, right? So what I will do is, I will take one line, small line I will draw because my process has to start now here. Okay. Then what I'm going to do, I will just take my I have to give one more line also I will take because here the ATM system also has to start, right? So I will take little small line. Okay. So now what I have to do, first the customer has to insert the card, right? So what I will do, I will start my process from here to here. Got it? Here to here. Okay. My lines are like little bent. So you draw the lines properly. Okay. So here what I'm going to do is, my customer has to insert the card. So I will just write over here. I will just write over here. The first step, what has to be done? Don't do it with the box. Okay. Just you write down. I'll erase that box. Insert card. Okay, so the first point will be, my customer has to insert the card. Fine. Okay, so my customer has to insert the card. So once a request has been sent, here what will happen? Here you need to do the box. Okay, so here my customer has been started. So this is a small box. Okay, you have to place it properly. Yes. So okay, so here also I need to do the same thing. Fine, you have to understand, it will take little time, so you have to understand and you have to do it. So here also my process has been started. So what I'm going to do, once it will validate, it has to send me back, right? So here it is going to send me back. So here it is going to send me back. Without, you can see any kind of your arrow mark here. Please be careful while doing. Okay. The previous one was arrow mark. Here arrow mark is not there. So here what I'm going to do, I have to validate the PIN. So what I will do, I will have to write over here that I have to write here validate PIN. Okay. So if I'm going to validate here I'm going to validate the PIN. Fine. So once the validation process will over, 1 minute, this one has to be little down actually, because here validate PIN means here I have to give the lines. So here I will just extend that line till here. Okay, so here validation of the PIN has done. Fine. Okay, so now next what you're going to do, you have to request for the PIN. So who will request for the PIN? The ATM will request for the PIN. Okay, so here I'm going to take the arrow mark and I'm going to request for the PIN. Here I'm going to request for the PIN. Okay, so here what I have to do, again I have to start with the straight procedure because I'm going to request for the PIN. So here what will happen? Here I'm going to write. Here I'm going to write, this is the request of the PIN. Write down here. This is the second stage, the request of PIN. Okay, fine. So now what is the next stage? What we are going to do? In that time, it has to enter the pin. Okay, so what I have to do, I have to take the whatever the access you are doing, that time you have to take with the arrow mark. So here I'm going to give the access to the pin, right? It has to connect. Yes. So here what I'm going to do, I will do the small box because my process has been started. Okay. So request for the enter the pin. So next what you are going to do, you are going to submitting the pin. So till that time, this one was ideal. Okay, my bank. So now bank has to start processing also. Till here it was ideal. So here it is going to start the process. So what it has to do, it has to check for the pin. Okay. So for that reason, I have to submit no first. So from here, I will submit the pin over here. Okay, so I will just write down here what it has done. The third stage, what we have done here, we have requested. Sorry, here we have to enter the pin, right? Enter pin because requesting is already over. So we are entering the pin. So once we have entered the pin, it has to submit the pin. So it has to submit the pin. So here I need to write, while doing, be careful and see each process and do it properly. So here I have to write fourth one, submit pin. So here it has to submit the pin. So once it will be submitting the pin, what will happen? Then again it has to validate, right? So here I have to do the diagram here. This one has to connect it, okay? You please connect it. Don't think that I have not connected. Here I'm going to write what I'm going to do over here. I have to validate. That is my fifth stage. So I'll write validate pin. I'll enlarge it, don't worry. Here it has to validate the pin. So now next what you are going to do, once the validation will over, okay, once the validation will over, it has to send it back right here. So here I will take, so here so now I have done here, you are going to validate it again. So you are going to send it back. So where you are going to send it back? Again, you are going to send it back to the customer through your ATM system. So here I will take a straight line and here it has to it has to send it back. So here where it is going, so here you can do it. I have given here one partition, okay? So otherwise 1 minute. Here you can do like this. You just connect it this one. Okay, one more you take. Okay, because that time also it will take some time to validate. It won't validate at a time. This one has to be straight. Fine. So it cannot validate at a time. So you are going to validate and then you are going to send it back. So to whom you are going to send it back? Directly through the ATM, you are going to send it back to your customer. Fine. So I have given it back. So next what will happen is here again you have to go for the options. Whatever the options you have, you are going for the options here. Okay, so here what will happen, the validation question has come but the acknowledgement has not come, right? So here we have to send the acknowledgement. So who will send? From here the bank directly it will send towards your here to start the next process. This small box whatever you are seeing, that is nothing but that is a process. Okay, so now here it will write that valid. So here I will add. So here I have to write my sixth stage. What is my sixth stage? So my sixth stage will be a valid PIN. That acknowledgement, it has to come from your bank to the customer. So this is my acknowledgement has come. Okay, so now my acknowledgement has come. Fine. Okay, so now what you are going to do, next thing here, okay, so don't keep it in the box, you just remove the box. Fine, so I'm moving towards the next one. Once it will be done, next what you are going to do, you can go for the next one. Okay, so here you have to go for the options. So suppose I'm going for the options are select withdrawal, then I have to take my this one. So I'm going for the withdrawal options. So I will click on here, and this option also has to be work on. So this ATM system, it has to be next ideal position till here. Now whenever I have given any option, so it will start activated, and the process will start. Okay, so whenever the process will start, here I need to write, so here it has to start like ideal line. Okay, here it has to start with the ideal line. Fine, so here I have to write here the options. I will write over here the seventh stage. What will be my seventh state? My seventh state will be if any options. So I'm going to select the withdrawal option. Okay, select the withdrawal option. Okay, select the withdrawal option. Next, once the selection has done, next what will happen? It can display again the the menu. These things are all also you can write according to you. Here it will display me the again the menu. Now next, how much of amount you want to withdraw, right? So here what will happen? Here again it will send back one more process to start. Whenever process has to start, that time you need to go for the arrow mark. Okay, so here the process has to start, so I will use start. Okay, so now here what will happen? Here this one will become ideal for the timing. Okay, fine. So now this one here, what I'm going to write here, it has to go for my eighth stage. What will be my eighth stage? I'm going to write here, display the menu. If you have any menu, like what is the amount I'm going to enter, that things it is going to give. So display menu. Fine. So now what will happen in the next case? The customer has to enter the amount. So here the customer has to enter the amount. So here it has to send like this arrow mark, and here again one more box it has to create, because again one more process has to start, right? So here I will write, and here it became ideal. This side it will become ideal. So here I have to write, go for again one more box, and I will write over here my next one. So here what I'm going to write here, enters the amount. Okay, so ninth stage, enter amount. Okay, so this is my enter amount. So once that amount has been given, so first now it has to go to your bank, right? So this processor has to send this one to my bank. So till the time bank will be ideal. So here I'm taking this one and I'm sending towards my bank. So till that time my bank will be ideal case only. Okay, now this one will start processing. So here I need to add the processor. Okay, so it has to connect over here. Fine. So here it has to check the balance, right? So here I will give and write over here 10th one, check balance check the balance. Okay, and if it is there, then what I need to do over here, I have to keep one more, and I will keep over here, and I will write the next stage. Okay, the next stage will be 11th one. So here my stage, it has to check, okay, that balance, question mark you have to give, balance is there or not. Okay, the amount whatever has been entered, okay, that it needs to check over here. So that validations it has to send now. So for that you need to draw one more processor which has to work on this itself like this. Okay, so you need to do, and also you have to send the uh, like arrow mark from here to here. You just check it out properly and do it. Then we are going to send it back from here to there. Okay, once it will get it back, valid the amount, it is going to send it back to the customer. So from here directly we are going to send it back to the customer. So till that time he will be an ideal case. Okay, he is not going to do anything. So here the customer is going to be activated, and what will happen here, it has to check the valid amount. This is my next stage, right? So I will write down here. I'll write down here uh, valid amount. So it has to check that it is a valid amount or not, right? So it has to check over here is a valid amount or not. Once it will be checked, then the next case will be it is going to dispense the cash, right? So here I have to draw one more box. So here I will draw the box over here. Small one I'm doing because I don't have space. So here what will happen, this ideal cases will be continuing, okay, from ATM, and here also I will give the connectivity. Now after this valid amount, it has to, the ATM has to dispense the amount or cash. So it is going to dispense the cash. It is going to dispense the cash over here. Okay, next process. So I will add over here. I'll just write down here my 13th stage. What is my 13th one? Has to dispense the cash. Dispense cash. So this has to be done. So now here, once the cash has been dispensed, next one will be what? We are going to insert again the 14th stage. Okay, so here what will happen, you need to collect the money, right? So you have to send this one for the next processor here, which is going to be activate now, and here you need to do the processor. Okay, and here I will draw one more here. I'll write my 14th stage. So what is my 14th stage? Collect the amount. So I'll write here, collect amount. Okay, so that is done. Collect the amount. So next what you are going to do, next this process has been started, it will display you the account balance, right? So here you need to draw again, it has to display the account balance. So here you are going to send it. So here you have to do it in this way, and right over here you need to draw over here 15th stage, that is display balance. All these things will be near functions. Okay, so display balance. Fine. So once it will be done, next one here it is going to start this process already. Okay, it is going to give this one. So here you need to connect over here. Okay, don't forget please. So you need to connect over there. Okay, so next is, you don't keep it in the box, I have already kept it. So next one is, I'm going to give again one more box here, the last one. Okay, so here I have to eject the card, right? So this one will be my ideal like this only, and it is going to send over here. This is my last one. Fine. So here it will tell me to eject the card. Always you have to join in the beginning. Okay. So here my last step. So here in this last step, I have to write 16th one, eject card. Okay. So, and in this side, as it is ideal case, the bank, just you need to draw the line. That's all. Okay. So this is all about your sequence diagram of your uh, ATM system. Now the assignment will be sequence diagram of I will give you the assignment here itself. I will write one more assignment, sequence diagram of for present management system in the similar way. Present management system. Okay. Okay. These two are your assignments that you have to draw accordingly. Okay. How I have done in that way, you are going to do it. Fine.